Hey, this is Dave coming at you from the job site. I haven't done a video in a while, but we've just been running wires and getting pulled off doing other projects too. And Justin's out with a knee injury, so he's recovering from some surgery for the next few weeks. So I'm just here doing it alone. We've just run stuff in really rough for now because we really are trying to focus on the rough inspection upstairs. This will just be drywall later, like well beyond the house project. So we're running the wires, and you can see we're not even bothering stapling anything right now. This will most likely get done before the inspection, but I look at it like if it doesn't need to be done for the rough inspection, then I'll leave that for now, and then maybe it would end up where we could get approved, and then we could still do this later and just keep going with a forward motion with the insulation. But anyways, I want to make this, there's just so many videos that show you how to wire a switch, wire a three-way, but I'm trying to come up with things that maybe some electricians or some people who are do-it-yourself might get in trouble with not doing things right. One of them is more towards like carpentry, but I guess we might as well, let me see if I can just find an open one for an example. So we have an I-joist here. I love drilling through them. They're nice to drill through, but it's good to keep it minimal. The people who jurisdict the code on this is ultimately the city or township, but they basically say that the manufacturer's recommendations is what they go by. So as long as you're following the actual manufacturer, which like this is what Weyerhaeuser, I believe, I can't remember exactly how the name's pronounced, but you can just go to their website. They tell you everything. But just so you don't have to, and I already did, unlike conventional lumber, if you take the 1/3 span, I might have covered this a little bit in previous videos, but if you take the full span and chop it into thirds, in nominal traditional lumber, you cannot drill into the middle 1/3 of that. So just always think of normal lumber and I-joist as the opposite when it comes to drilling that type of way, where you're trying to figure out in the span where you should drill. Okay, another thing says right in the manufacturers that any hole that is like, I believe, 1.5 inches and bigger, it could be bigger than 1.5 inches, but let's just, to be on the safe side, I always go against myself, especially if you're drilling into structural stuff. I'm just going to assume that 1.5 inch hole is included in that. That's where the rules start getting where anything that's bigger than 1.5 inch hole or 1.5 inches, you want it to be in the 1/3. 1.25 inches or smaller, you can pretty much drill anywhere you want. Now, there is one little rule of that. Some manufacturers say from the point load, which this is not. It's actually technically the back wall is the true bearing load. But just to be safe, let's just say that this is the bearing load just because that's way back in there. Let's just say that this is the actual foundation wall. This is where your span starts. Even if it's a smaller hole, you'd want to come out 12 inches and then you want to go up halfway to center and back. That lower square that is formed, don't drill anything in there, ever. Not even an 1/8 inch hole. Just stay away from that area. As long as you stay away from that area, electricians, since this is technically an electrician video, you're not gonna, if you're drilling a bigger hole than 1.25 inches to run wires, I would recommend you just switch to a smaller bit and drill multiple holes. And then another thing, let's say you have, just for the sake of math, a 2-inch hole, and then you have to drill another 2-inch hole. It has to be twice the distance of the diameter of the hole, and that's from inside to inside of the circle. So when you have both circles drilled next to each other, that measurement is whatever wood's left between it. That's got to be 4 inches. So 2-inch diameter hole, measure over times 2, 4 inches. That's your other hole, but the wood between the two holes, that measurement's inside to inside. So whatever wood's left between the holes, that's 4 inches. So that's another pointer that you could really, really get in trouble if you just start drilling holes. Like I've seen it where like electricians have just Swiss cheese that, and that's a tempting spot because you come out of the wall and you want to daisy chain some plugs because the wall studs are too difficult to drill in. Well, it's easy just to drop a hole and drill real close. You kind of want to stay, and technically you can, you just want to be up above the center mark to get out of that lower square. It's really weird, but they've done all the testing on it. And They mostly want to see holes drilled in I-joist in the middle 1/3. You can, by code, cut a big old hole, huge square hole in here and leave basically an 1/8 inch of OSB on the top and bottom. I would never do that, because if I was designing a house that had HVAC that was that funky, I'd probably design the house where there's already bulkheads or some type of false wall, false ceiling square that you can run ductwork within. Because if you're needing to knock a hole in the center of that, then we call it PPP, and that stands for piss poor planning. So anyways, another thing, let me just cruise upstairs. You know how I do it. I don't really plan too much. I actually wrote down a couple talking points, but I just try to cover the stuff that, no one else does. Okay, another example of what you don't want to do when it comes to framing. Never drill through a truss. Like, never. Okay, that covers that. Okay. So we set this stuff up. We have the kitchen wired. I might be slipping on my pimping, because I think I used to run wires neater when I was younger. I think it's still pretty neat, but I guess as you get older, you realize that it doesn't really have to be too neat. You just want to make sure it's right, but we are trying to neaten it up. Let me see here. Oh, let me just discuss how I actually go about laying out a house. How do you wire the thing? First of all, there's not going to be an electrical print unless if it's a cookie cutter neighborhood, depending on if the engineer or the city or township requires an electrical print. Most of the time, mine did come with an electrical print. We would never wire it the way the print shows, because it's just basic stuff. It's like one light switch here to a light, 4 plugs in the room. That's it. So I'm losing my train of thought. Oh, basically, most of the time you're not working off of an actual print where you're like, oh, it says right here, there's a switch that goes here. Let's put a switch here. You're usually going to venture off a little bit, because we all have a little spark of creativity in our brains, and we want to kind of steer away from that basic stuff. And so that's going to leave you in a situation where you're like, well, what do I do now? So the way that I approach it, because I have that too, even though I'm an electrician, sometimes I'm like, what do I want to do here? I mean, Nikki and I wanted to go with some wall sconces. We wanted to kind of, first of all, you walk every single inch of your house and feel and act lazy about it. Like when I'm lazy, I just woke up. When I walk into this room, where do I want the switch? How does it make my hand turn? So here's a good example. When this door here opens this way, you didn't want the switch on this side where it almost kind of makes sense that it would be, because it's right where the knob is. But when you open this way, you either have to let go of the knob now, reach back to where now your back's facing the hallway to flip it up. Or you're gonna have to reach out with this hand, which is awkward because you're kind of reaching out like this, kind of, right? So in a case like this, it makes more sense just you open the door, you got to let go of the knob anyways, and you just come right in, and your hand's just lazy right there, flip up. So stuff like that, you might have people, and there's also just opinion. It's preference. Some people might have wanted, that box is in the way of the proper height, so it just made the decision easy. But in my opinion, that actually it just fits the natural flow better. And then another thing, we have a lot, let's just count real quick, hallway switches. 1, 2, 3, 4, even one here, 5, 6, 7, and then we don't need any here, 8, 9, and those 9 switches, there's going to be 7 4-ways in this circuit. That means that no matter, because it's just such an open area, no matter where you walk into this hallway, it's nice to be able to turn it on. We didn't put them through here because this is going to be a wet bar that blocks this off, and then you're never going to really be walking from the dining room in through here with the hallway off. Most likely, if you're going to be in the dining room, it means that you're throwing a party and that you're having a dinner and the hallway light's either already going to be on or it's just not going to matter because there's already enough lights in there. So that's the first thing you do. Just figure out where everything goes. And I can tell you right now, that's the hardest thing. If you're an electrician, you understand the electrical theory. Residential is simplistic compared to industrial and commercial. So electrically, I'm able to just really quick in my head do it. The placement, the heights of the sconces, what chase you want them in, that's where my OCD just grabs a hold of me and takes me for a ride, because I was in one wall, I think it was the dining room wall, where I swear I nailed the boxes on. And I know better not to nail them all the way, and I just tack them. See, I must have pulled the boxes off of, there was one wall where I must have pulled the boxes off 7 times until I realized, like, what am I doing, dude? It's just a plug on the wall. Just relax, dude. But yeah, you're gonna find that that's the hardest part of it. And then the next step, okay, you find out. So Justin and I, we basically went through the entire house and we nailed on every single box in the house, except for the basement and the garage, because the garage is cluttered. We have a plan. We're gonna wire the garage or the basement first, then we're gonna clean the clutter. It's cluttered. I'm fighting my urge to be a pack rack, but everybody I practically know is a hoarder, so obviously it rubbed off on me a little bit. I'm fighting it. I'm really trying. But a lot of the clutter that I have is good wood, is good lumber. At the end of the job, when I finally know I'm done building, it's either gonna get burned in a brush pile or given to somebody that really needs it. But anyways, wire the basement. Once the basement's wired, then time to clutter the basement, and then we'll wire this. But for now, we did the whole house. And then I have an example right now that I'm working on. And electricians, I find, and tree guys, arborists and electricians are the most rude to each other. We all have our different ways. Some electricians use the special thing that crimps and strips. That's fine, it's preference. I'm never gonna knock anything of what anyone else does. If it works for you, then it's working for you, man. Knock her out. But what I do is, if I have a box up here like this, and I know that my camera's dropping down, I'm just kind of talking more, thinking than filming, but I always bring the power into where the stud is, on the side of the stud as best I can. And then when you bring the power in, what I mean by that is like the home run wire that basically comes from the panel to the first device box. Then I run the power in. I wrote this arrow. I just started at just this job because I don't know, but anyways, I represent power by just marking X. That's all you have to do. I write that it doesn't matter, but it's like, okay, I know that wire's the one that comes from the panel, okay. And then this one's X. That's just that loops out. So what I do is once you have all your placement of your boxes, you know how you're gonna kind of do your switching. Let's run your power all the way daisy chaining through every single box that's gonna be on that same circuit. So then I ran from here, up, over, and then I needed power here. And then I needed power from here over to the wall sconce three-way. And then I'm gonna power from here to here. And I'm gonna power from here to the closet, into the bathroom. Sounds like a lot, but when you do the calculations, even at 75 watts per bulb, I can put 14 bulbs on this circuit. And these are all gonna be LED, so they're never gonna see. The way that you figure it out, it's the amperage, 15 amps. It's a continuous load, so that's gonna be 3 hours or more. So it can only be used at 80%. So basically when you take 15 amps times 120 times 80%, which is times 0.8, whatever that comes out to be, that's your wattage. And that 50 amp circuit is at 1,440 watts. Then all you gotta do is take the nameplate rating of the fixture. You have to take the fixture rating of what light bulb could be put in there. Grandpa might have some incandescent light bulbs up in the attic and it's like, hey, put all those in there. Well, if you figured it out to be a 13 watt bulb from an LED, you're gonna trip the breaker constantly. And if the breaker fails, you're gonna burn your house down. So that's the way that you figure it out. 15 amp circuit times the voltage, 120 volts. I believe that comes out to 1800. You multiply that by 0.8 because you can only load something that's running for 3 hours or more at 80% of the circuit. It brings it down to 1,440 watts. And now let's divide 75 into that. And then the magic number, I believe it comes out to like 14.4. Well, you can't have 0.4 or something, so you have to do 14. If you do 75, or no, that's at 100 watts. That makes sense. 14, it comes out to 14.4. Yeah, that's based on 100 watts. So I'm going against myself saying that every single bulb in my house is going to be 100 watts, which it is not going to ever be that. At the most, the garage lights might be 100, but most likely garage lights are good enough at 75. So that's how you figure that out. But back to how you do it. Power always on the wall stud first. Here's a good example. I've got 2 in here. It's next to the wall studs. They're both going to be marked X. And I don't know why I didn't mark them X, because I'm probably working by myself and I know that that's power, but you want to make sure you mark them so you know. And then I always bring the switch leg one that controls the light. Whenever you hear the term switch leg, it is just the wire that is only hot when it's being controlled by something upstream. So the switch controls this. These will always have power. That's why that's power. This switch leg wire that goes from the device up to the light is called the switch leg wire. That only has power on it when the switch is on. That's basic stuff, but whoever's watching this, hopefully maybe that helps you. So then once you have all the power wires in, it just, in my mind, what it ensures is that you don't end up with a dead wall. There's something weird, like, it would be like asking me to build a crooked wall if you told me, I want you to run the wire from here. I want you to run the switch leg wire first. I'd be like, dude, that's just not how I do it. Because another thing too is when your power wires are here and you're really throwing and going, once that switch leg wire goes in and you know that's the last wire, these are already right up against a stud, and then you can just slap that top switch leg around and just start stapling right away. So it does help practically too in the physical world of actually installing it. But always run your powers first, all the way through the entire circuit. And then from there, it will also make you better envision how your 3-way switches are going to be done, how your 4-ways are going to be done, just how you're going to switch stuff. Another thing that is a weird thing in electrical that I've never heard mentioned before, but I think it's worth mentioning and it could really throw people off. Here's a scenario where you've got power that comes from here, but it also goes to there. And then you'll end up in situations where now I also need to run. I'm trying to think. I have an example of that. I'm trying to figure it out. Oh, here's a good example. I found it. You come across it quite a bit where here's a box that needs power, constant power, because this is a separate circuit, so ignore that for now. That's just a hallway circuit, so this one switch is on its own circuit. These 3 are on its same. You have power coming in, and then you're going to have 3 switch legs coming out. 1, 2, 3, and not switch legs. These are actually traveler wires. They run over to there. And then the traveler wires then have switch legs that run out to the lights. But then you also need power here. So then you end up with this conundrum or whatever, you end up with one neutral wire that's redundant, because you're still going to have a neutral wire in the traveler on that circuit to go over there. Well, actually 3. And then you're going to end up with the actual power wire also going over there. And a lot of electricians are like, what do you do with that? Well, with me, I always tell people, wire it almost like you would a ground wire in a panel where the sub panel becomes isolated. Like, in other words, the neutral and the ground become isolated from the main panel out to the sub panel. And what I mean by that is when I bring this in and wire it, let's just say that you can tell that, see how there's 6 wires in here. 1, 2, 3, 4, 5, 6. 3 of the travelers, 3 of the switch legs. Whatever traveler goes with that switch leg, I tie those neutrals together only. You can see it right there. See that? Just 2. The power that comes in here, the only reason why the power is in this box is because it feeds, you have to have constant power for the outside deck lights, the sconces out here. That's another pointer. You always need a power wire in a box whenever there's a single pole switch. Whenever there's a single pole switch. And then when you end up with those redundant neutrals, in other words, we needed to bring the travelers over here, obviously, but we also needed to bring the power. So do you tie these traveler neutrals to this neutral on this power when it's already tied together on that side? That tells me you're just looping the neutrals. It will electrically work, but I look at it like to keep the confusion less. If an electrician ever had to isolate the problem, if you have only these neutrals tied to where they need to be, like, in other words, once you have the neutral tied into one location, from that downstream point, just isolate everything. So I've beat that subject to death. And let me give you an example of something pretty cool. It's the first time it's ever happened to me, actually, because this is a bigger home and I've done some interesting things. This actually happened by accident. Here's a box that is a weird scenario where there is no power wire in here and there is no switch leg in here. This is all travelers. There's 6 wires. Here's the 4-way switch, 4-way switch, 4-way switch. So this is kind of cool where all you see is 14.3. There are no power wires and there are no switch legs. So that's cool. I thought that was cool. What else? Oh, another thing that's really been bothering me. I think it's the thing that bothered me the most on the entire job. I mean, talk about OCD. I love this blue. I love the blue 14.3. I love the fact that they changed the color. It actually makes the inspector's job easier. That's why I think originally they said that they changed that some years ago. It's not code. For years now, I started wiring when everything was white. 12.2 was white. Matter of fact, to be honest with you, I started wiring when the stuff was black, way back in the day. Like when I was with my kid, or when I was a kid with my dad, he'd buy it was still Romex. It still kind of felt like the Romex. It wasn't like that old cloth stuff, but it was actually black electrical wire. I think it was like the early 80s they pushed that product for a while. But anyways, I'm just rambling here now at this point. But that's pretty much where we're at. I thought I had a couple other pointers. I have all types of tips and tricks. It's hard for me to film and do it at the same time. Oh, another thing, people might look at these electrical boxes and wonder why I just didn't do plastic ones. Well, this is an obvious reason, is because we want these to be set in specific spots, because you can see that they're not like being nailed right up to the spot. You could put a block and then use a bracket nail on box, but we have so many blocks left over. If you just drill, make sure that's 1.25 inches, and you can see that there's like enough room around that to where if people see this, they're like, well, technically you're not supposed to alter something. I don't think this is altering this. You just take this, clamp the wire, and as you clamp it, these screws go out kind of far. I just take my linesman pliers on an angle and just cut the backside of the screw off. That's not tampering with the clamp, because it's just cutting off the back edge of the bolt. You're not affecting the clamp's function in any way, shape, or form. So I would even argue with an inspector about that. I'll tell the inspector, you're wrong, I'm right, I'm big, no, I'm kidding. I'm big, you're small. I'm just joking. Anyways, back to one other pointer, and I'm saying this because I almost want to get cut by a knife in the future, because it's just me being bad with karma. But you have a sharp knife, keep your blades sharp when you're cutting the Romex. I cut Romex. I'm old school. I know that there's tools. You got the strippers. They pull it out. They pinch it right here. You pinch it. You pull it out. You pre-strip with the whole crimp strip. I'm always afraid of those sharp ones. They'll nick that wire and you don't know it. I've just never been good with that. Another reason why I do this is when you end up with like a 4-gang box or something like that, you're going to have a lot of wires in there. When you get to my age where you just no longer want to think about stuff as much, you like to write down on here all this, like Sharpies. Like I wish I had a box that wasn't trimmed out yet, but I basically just write, mudroom switch leg, main light, mudroom switch leg, sconce lights. And then you put them in order as you go. That's another very important tip. Whatever switch legs or travelers go here, drop them in the slots. Always put the powers on one side or the other. This traveler goes with this switch, that traveler goes with this switch, this traveler goes with this switch. Tie all your grounds in and all of that stuff. And then do your neutrals next, and then do your hots. Whenever you disconnect something, disconnect the hot stuff first, then the neutrals, then the ground. That's just the way that we're all of us electricians are trained. Non-union and union, I believe that we're all trained the same way. And one secret to being an electrician that we don't tell anyone, we always work on this stuff when we have the power turned off. It's very rare when we work on it hot. There are circumstances where you do. If you have an office building going on, they're on the computers, you can't turn it down, you're working on stuff. Sometimes you just got to wire a plug in hot once in a while, but you know, electricity, you know, a good enough zap, you don't even have to finish your coffee anymore, you know, you just don't even drink your coffee anymore. Another pointer I'm looking at. When we're running the wires, you can see that these are loose. I don't even bother stapling any of the stuff, even when it is for rough, because this does have to be done for rough inspection. But if I'm running wires and I know that I'm still gonna have wires dropping through the holes coming down to switches and stuff, I don't put one staple. Once in a while, see like that. I call that a tack staple. It's not driven in all the way. All that's doing is helping me keep the right amount of wire I need to make it look nice. A lot of times I leave those a little long. I've left stuff crazy long. Some electricians would see this and be like, wow, you're wasting a lot of wire here. Well, I beg to differ, because the way I see it, whenever I've tried to make the wire the exact amount I need and really try, first of all, you're taking twice as long because you're trying not to waste wire. Second of all, it just seems like 9 times out of 10, you always need to slack back up, like slack a little bit back up where you're going. It always just seems like you didn't give yourself enough when you're running it. The way I see it, if you leave an extra 4 inches of wire, which is quite a bit, on each one you do, even on a house that's this large, you're probably gonna waste 100 feet of wire. And when you're dealing with a project of this magnitude, wasting 100 feet of wire to gain 3 hours of time back, like of just going fast, and that, like, I don't care if I waste a lot of wire, and I don't mean like I'm careless with it. I just mean that I don't sweat like this wire being this much longer. I don't care if when it gets cut, it gets cut. When you have those little pieces laying around, you could go after the whole job, after not sweeping up at all, pick up all the wire, lay it down, and measure the length. And I'd be surprised if you even have 40 feet of wire. Well, 40 feet of wire is like $20. So a good electrician gets to the point where they can run fast, accurately, and still not waste hardly any wire. That's what makes a good electrician. It's what makes any good trade a good trade. Carpenter can work fast, accurate, his walls are plumb, and at the end of the day, he doesn't have a huge boneyard laying out in front of the house. Another tip I just thought of, and then I just forgot it again. Oh, us electricians, or at least this is the way that I've been taught, don't be the guy that runs a wire, like I said. You're like, oh, okay, I got one wire ran here, and then they staple it. And then, oh yeah, I gotta run a power wire. And then they staple over that staple and staple over that. I've seen it where electricians try to make it look neat, where they put a staple, and then they go an inch, put the other staple over the other wire, and then go an inch and put another staple. That, to me, is the equivalence of a plumber using too many couplings in his pipe. It lets you know that he's not planning his job. It's like, this is kind of what you have to go for. And I'm not saying I'm perfect. Trust me, you go somewhere in some of these houses, or somewhere in this house, I have a couple stacked staples, but it probably meant I was sweating, I was awkwardly placed on the ladder, I just wanted to get the wire stapled. But this is the way that you kind of want it. You see, I got 4 wires under each one of these staples, and it's just one staple. There's not multiple staples stacked. In other words, you're not pinching a wire front on back on staples. Another thing too, never ever drive your staples in to where your wire cannot wiggle. So you see, wiggle, wiggle. See that? Nice and loose. I mean, you've got almost like an 1/8 of an inch gap, right? While we're here, that's another pointer. Wait, I heard someone say, why would you put 2 staples there, right? I just heard them. Why would I put 2? The reason why you put 2 staples here, code is 12 inches from the box. I'm never against more stringent codes, but this one is the one that I think that should be a better code, where it should be probably 6 inches from the box. But I do know that there's circumstances of why the code's 12 inches. But in a case like this, you put this staple, that's fine. But when you push back on this wire, that can pop out of that box, because this right here, without that staple, it has a fulcrum point and it wiggles. It gets rid of the bounce. And putting that second staple, even if it's just loose, look, it just can't rock anymore. So this wire can never be pushed out of the box after it's been stripped. That's why. I call it, it gets rid of the pivot. Putting 2 staples, it just gets rid of the pivot to where these can't come out now because that one holds that from shifting forward. I hope that makes sense. You're getting rid of the fulcrum point. That's about it. I'm hoping that some of these tips are just hands-on trades tips. Oh, one more really quick tip. I had my friend Greg working with me, and I had him run a wire up through here and over the top of that nailer right here. And then later I have to drill all these holes. Now I knew the wire was there, but if I would have forgotten the wire was there, I can pretty much guarantee you that I still wouldn't have hit the wire. And the reason for that is because I was trained every time you drill a hole. Let's just pretend I got my right angle drill here. I'm about ready to come up here and I'm gonna drill right there. Take the opposite hand, slap the back. Oh look, wire. Every time you drill a hole, never ever drill a hole anywhere without slapping your hand. And not only will I slap my hand, I go like this. I slap my hand and I move it out 6 inches. I know it looks kind of, well, you can't say that word anymore, but you slap it here and I just go like that. And that way you know that there's not a gas pipe that's 3 inches from it either. You just kind of slap and move my hand back. I'll slap, move my hand back. And that way you don't have to, but when you're experienced like I am and you're older and you don't want to move around anymore, I'll a lot of times just walk over here and go like, nothing's there except for that wire. I'll pull it out of the way, drill your hole, and push it back. And then I guess the last but not least, one of the most important things is never trust your farts. All right, this is Dave signing off.